This video discusses a development to SimCenter FloTHERM XT which enhances the design space exploration and optimization by making use of external third-party optimizer software. Once the thermal analysis in SimCenter FloTHERM XT is complete, you are presented with a single snapshot of a design. Many questions may still arise. For example, a simple "what if I change this?" or, at the other end of the spectrum, what is a perfect optimum design? It is essential that a user can quickly and easily make changes and then set up subsequent runs. Currently, our user base has access to two methods of parametric study: manual variation and design of experiments, better known by the abbreviation DOE. In the first method, the user must manually define the values of any parameters that they wish to study. This could include geometry dimensions and smart part properties such as the number of heatsink fins or a change to the material applied to parts of a model. The individual scenarios are set up with these values. Alternatively, DOE can be used. In this instance, a user will simply define the minimum and maximum range for two or more parameters, define the number of scenarios to create, and the software will automatically fill in data to create the best coverage of a design space. A cost function can be added to drive the software towards an optimum, and response surface modelling can be utilised to numerically predict the results in the gaps. While this is a tried and tested method, the downside is that you may need a large number of experiments to accurately fill the design space and obtain sufficient resolution in the response surface. So, while SimCenter FloTHERM XT includes tried and tested optimizer tools, there are other methods from other tools. To allow users to benefit from such tools, SimCenter FloTHERM XT 2019.1 has a new feature to communicate parametric settings to such external optimizer tools. The new option, External Optimizer, has been added to the parametric study area. It is also worth mentioning that to aid usability, when a project contains any parametric study already defined, the appropriate button is shown depressed, giving an instant indication to the user. Once the study has been activated, the user is able to set up the input and output variables for the study. For the input, you are not limited to numerical entries such as dimension, as a number of these external optimizers can accommodate input to say the material applied to a part. It is possible to define an ad hoc or linear step variation, as in a manual variation of a range as in DOE. Usually the output variables are left as just recording the value. Cost functions for the optimization process are usually set in the external tool. It is also often possible to define constraints on the input or to define a study to say minimize my heatsink weight but ensure that the junction temperature does not rise above 90 degrees C. Once the parameters have been set up, it is then simply a case of creating a task file which can then be imported into the external optimizer tool. Scenarios are generated and passed back to SimCenter FloTHERM XT for solution. Results are shown in the scenario table and also passed back to the optimizer tool. One such external optimizer tool is HEEDS. HEEDS includes a state-of-the-art optimizer process called Sherpa. This is proprietary design space exploration functionality that is used to simultaneously leverage multiple global and local search strategies and adapt the search as it learns about the design space. HEEDS fits effectively with SimCenter FloTHERM XT model setup. This method requires no model simplification or model fitting. Using the hybrid adaptive intelligence search allows you to find better designs in fewer evaluations, ultimately reducing product development costs and product design risks. To fully exploit the benefits of HEEDS driving SimCenter FloTHERM XT, a new portal was made available in HEEDS 2019.1.1. The portal drives the new external optimizer interface in SimCenter FloTHERM XT to modify the input parameters. The settings of these made in SimCenter FloTHERM XT are automatically imported to HEEDS, run the design scenarios and extract the results without requiring any scripting from the user. In summary, using HEEDS linked to your SimCenter FloTHERM XT model helps you reduce effort finding optimum design solutions, but also provides valuable insight into product design alternatives to drive down development costs and risk.